The chapter is lines and angles and triangles. In this figure, it's given ADC. ADC is equal to AEC. AEC. So it is given angle 1 is equal to angle 2, and AB is equal to BC. Now we have to prove AE is equal to CD. So we will take the angles as angle CEA as 1, this as 2, this as 3, and this as 4. So when you write in the exam, you have to give the names like this. Now we have to prove AE is equal to CD. So angle 1 is equal to 2. Now angle 1 and 3 will form a linear pair, and angle 2 and 4 will form a linear pair. So we will write it as angle 1 plus angle 3 is equal to 180, and angle 2 plus angle 4 is equal to 180, from which we will get, the reason is linear pair, but already 1 is equal to 2. So we can say angle 3 is equal to angle 4. You can equate 1 plus 3 is equal to 2 plus 4. 1 and 2 are equal. So angle 3 is equal to angle 4. Here. Now we will consider the triangle AEB and triangle CDB. So AEB and CDB. So in this, we got this angle is equal, and we have B as common in both the triangles, and we have AB and BC are equal is given. So we will write in triangle AEB, we will write angle 3 is equal to, in triangle CDB, we can write it is angle equal to angle 4. We will write this as 1. So the reason is angle from 1. Now again, angle B is common for both the triangles. So angle B is equal to angle B is angle, common angle for both the triangles. Now you have in triangle AEB, you have AB. So AB is equal to, in this triangle CDB, we have BC. So AB is equal to BC. This side it is given. Therefore, the triangle AEB is congruent to, now we have to write the same order. So AEB is congruent to CDB. So from that we will get AE is equal to CD. This is AAS congruence. From this you will get AE is equal to CD. CP, CT. Congruent parts of corresponding triangles. In this problem it is given these are two mirrors. PQ and RS are two mirrors, and they are kept parallel to each other. Now a incident ray AB is falling on the mirror, and it is getting reflected from this mirror. So this is a reflected ray. CD is a reflected ray. Now we have to prove AB is parallel to CD. Incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC and strikes the mirror RS at C and again reflects back along CD. Now you have to prove AB is parallel to CD. Now we will draw one perpendicular at this point. You would have learned in mirror in physics, you draw a perpendicular. This is called the normal ray, and this is called the incident ray, and this is called the reflected ray, and angle of incidence is equal to angle of reflection. So this angle is 1. I'll put the number as 1 and this as 2. So angle 1 is equal to angle 2. Angle 1 is equal to angle 2. The reason is angle of incidence is equal to angle of reflection. Now similarly, I will draw one normal ray here. So similarly, this angle, let it be 3 and this as 4. Again, this is incident ray and this is a reflected ray here. So angle 3 is equal to angle 4. Now BX is perpendicular to PQ, CY is perpendicular to RS. So BX will be parallel to CY. So BX is perpendicular to PQ, CY is perpendicular to RS, and PQ and RS are parallel. Therefore, BX is parallel to CY. So, since BX is parallel to CY, we can say angle 2 is equal to angle 3. Angle 2 is equal to angle 3, alternate interior angles. So I will just multiply by 2 on both sides. Twice angle 2 is equal to twice angle 3. So what is twice angle 2? It is angle ABC. So that is angle ABC is equal to twice angle 3 is 3 and 4 are equal. So you can write twice angle 3 as BCD. Angle BCD. Now these two are equal. Therefore AB will be parallel to CD because the alternate angles are equal. Therefore AB is parallel to CD because the reason is alternate interior angles are equal.